Slightly larger than Earth's moon, Jupiter's fifth moon, Io, is a truly spectacular object within our solar system. Created about 4.5 billion years ago, at about the same time as Jupiter, it is the most volcanic object in our galactic neighborhood with approximately 400 active volcanoes. It orbits the Sun at a distance of roughly 5.44 astronomical units. 1 astronomical unit is equivalent to the distance from the Sun to Earth, so this equates to over 500 million miles. That far from the Sun, very little heat reaches this active ball of rock. With an average temperature of minus 130 degrees centigrade, there is certainly not enough heat to spark the eruption of the numerous large volcanoes. So, what causes the almost continuous volcanic action? In a word, gravity. Io exists in a constant gravitational tug-of-war between its parent planet, Jupiter, and the neighboring moons Europa and Ganymede. The result of this perpetual battle is that Io's orbit is elliptical. This orbit causes the gravitational pull from Jupiter and the nearby moons to ebb and flow depending on the point of Io's orbit. Already elliptical in shape due to this effect, gravity pulls at Io much like our moon's gravitational pulls at Earth's water, resulting in the tides on a twice-daily basis. But these are effectively rock tides where Io's surface can bulge by as much as 100 meters. Compare that to the highest tides on Earth, which are approximately 30 meters. It is this perpetual movement and the resulting rock friction which creates the heat required, up to 1,650 degrees centigrade, to fuel the volcanoes. The lava from which fills impact craters and continuously alters Io's surface. And these are not volcanoes such as exist on Earth. When an eruption occurs on Io, the plumes can reach hundreds of miles high. This volcanic landscape results in a surface probably composed primarily of sulfur. But the compounds within the lava flows result in a kaleidoscope of colors across the landscape. The very thin atmosphere around Io, providing the equivalent of approximately 1/1000th the pressure of Earth's atmosphere, is composed almost entirely of sulfur dioxide. Not an enticing place for a holiday, then. But that is not all which makes Io such an amazing object. Jupiter's magnetic forces are responsible for the stripping of approximately 1 ton of Io's mass every second. This material becomes ionized and the resulting particles form a donut-shaped ring of radiation around Io. Some of those particles are pulled into Jupiter's upper atmosphere. As pictured by the Hubble Space Telescope in 2018, this results in spectacular auroras, much like the northern and southern lights we see here on Earth, but on a larger scale. We know Earth's moon has an effect on our planet, causing tides among other things. But does Io have any measurable effect on the enormous gas giant Jupiter? Actually, the impact Io has on the massive planet it orbits is immense. Io's orbit takes it through Jupiter's powerful magnetic force lines. Thus, Io is effectively turned into an electric generator. As this happens, Io creates 400,000 volts and 300,000 amperes of electrical current. Taking the path of least resistance, this electricity travels, via the magnetic field lines, to Jupiter. The result is the creation of enormous electrical storms in the planet's atmosphere. Another amazing fact is that Io always maintains the same side facing Jupiter. This causes the atmosphere on the other side to freeze. As Io orbits the planet, the opposite side is exposed to the Sun, causing the atmosphere there to heat and return to a gaseous state. There remains plenty to learn about Io, Jupiter's amazing moon. Who knows what facts Juno will uncover when it passes close by Io in February 2024.